Hi, I'm Tim. Welcome to our channel and thanks for logging on. If you enjoy these videos, do me a favor and subscribe to our YouTube channel right here at Watchbox Reviews. I would really appreciate it, and I promise to update this channel daily. If you like this watch, see it and purchase it on our website, thewatchbox.com. The timepiece on my wrist won everything under the sun in 2013. Time Zone Watch of the Year, GPHG Aiguille, the grand prize at the Oscars of watchmaking, and the hearts of millions of enthusiasts. This is the Girard Perregaux Constant Escapement LM. In fact, this is the 2016 version, 46 rather than the 48 of the original, and titanium grade 5 versus the white gold of the original. It's both more wearable and more durable. On my 16 centimeter circumference wrist, you can see it's an easy watch to wear for a 46 because lug to lug, it's only 53.6 millimeters, which means it's about the size of a 44 millimeter Panerai physically on the wrist. It's thinner than you expect. At 15.2 millimeters thick with a domed crystal and a sloped case flank, you could fit this under a jacket cuff. Between the lugs, a modern 22 millimeter span, and you will note that you can pull the strap straight down because the curved spring bar allows the strap to have full articulation, so you can wear this watch on a wrist as small as, in my estimation, about 15 centimeters circumference. The strap is robust, thick, black, matte finish, large rectangular scale alligator, folded edges, and of course calfskin on the underside with a full titanium deployant clasp. And it is a trigger actuated clasp. Spindly, spare, light in weight, and curved to match the underside of your wrist. It's a double fold, which I find works better for small wrists. And there's some ingenuity here, as the spring arm is also the swing arm. So you have a trigger system, and the spring for the triggers is also the swing arm. So this one can't pop open accidentally. You can also see echoes of the lug form in the buckle itself. Thoughtful attention to detail runs deep with this one, inside and out. The case band is rounded with compound curvature. It's a little bit like a pot belly, and you will note that the sharp cleft between the lug and the case band is probably the most dramatic horizontal feature of the watch. Lug tops polished, case band in satin, and the bezel blade-like, polished on its top and bottom, sloped on both sides. But you'll also note that when you turn the watch to the dial side, the bezel's fairly minimal, and we're going to do our best to show detail here, because the watch is essentially all movement or all dial, the two being one and the same, as the caliber 9100 manufacture movement is 39.2 millimeters in diameter and an incredible 8 millimeters thick, giving you unrivaled depth, so you can view the watch not just from top and bottom, but also from the side at slant angles to appreciate its details. What made this watch revolutionary? Well, it's among the most important modern mechanical watches. It's up there with the FP Journe Chronometric Resonance, the Jaeger-LeCoultre Duomet. It's up there with the Zenith Dayfi Lab, if they could ever bring the thing to market in more than 10 copies, because what's in here is a fundamental rethink of the escapement using modern technology. Let's talk about the caliber. Twin mainspring barrels in parallel at the top, giving the watch a 144-hour 6-day power reserve. Jumping down, you see what is described as the silicon butterfly. You see an iridescent purple structure pinned around a set of bridges that are evocative of Girard Perregaux's classic triple golden bridges in a nouveau format. What you can't quite see, and I'm going to do my best to express it, it's more visible from this angle, is that there is a small 14 micron thick elastic band. This entire bow around the center dial is actually one piece, and so is that elastic band. There are two wheels with 3 teeth each. 3 because 3 hertz is the beat rate of the watch, 21,600 vibrations per hour. And they are actually transferring the power from the mainspring to that elastic band, and each one impulses the band. The band then snaps, moving this rocker arm device that is hovering over the balanced center, and then that balance rocker impulses the balance directly. So these effective escape wheels never impulse the balance, and they don't even provide the force that directly impulses the balance. It's provided by the break point of this elastic band. So in other words, when the watch is fully wound, these wheels impulse the band snaps and applies a quantized amount of constant force with every snap to the balance. When the watch is fully wound, these wheels activate the snap of the band, and it applies the same amount of energy to the balance. So no matter how high or low the energy in the mainspring barrels, and the watch has 3 meters of mainspring, as soon as that band snaps, it and it alone impulses or provides the impulse energy for the balance, which is a free sprung balance for precise adjustment. So no matter how low the energy gets or how vigorous it might be at maximum wind, the same amount of energy, due to the constant elastic break point of that silicon band, always ensuring that the balance beats away impulsed by the same amount of energy, and thus it can be regulated with exceptional precision, and it maintains that consistency through its full 6 days of power reserve. Now, what else are we looking at? Well, it's a 28 joule movement that is entirely hand finished, although not conventionally. You will note a combination of sandblasting, so you have this media blasted rusticated texture on the bridges, and they are PVD coated to varying degrees. The bridges are made of traditional Swiss brass, but the PVD coat on top of the sandblasting creates a more industrial aesthetic. This is probably as close as you can get to a Romain Gaultier look without an actual Romain Gaultier watch. Skeletonized external mainspring barrel structures, you can see how they interact with a ratchet wheel with a double ratchet and pawl that effectively acts as the click to prevent them from turning backwards. And then underneath this bridge, right next to the crown, you can actually see the keyless works that's used for setting. The bridges on the caseback also designed in the form of the 3 golden bridge structures, and the watch is technically part of the bridges collection. Hand-regulated, hand-finished, you will see every edge is chamfered with a mirrored edge that is then blackened, so it's a bit monotone. It's easier to see with a loupe than the naked eye, but the fine finish of traditional horology is present and correct. All screw heads are black polished, and you'll find that the impulsing wheels at the center of this structure likewise are black polished. Let's see how close we can get and maintain resolution. So you can actually see the device that locks and unlocks these impulsing wheels at center. They lock and unlock, they impulse the band, and like a credit card to which you apply pressure between 2 fingers, as soon as you apply the pressure, it takes an arc form. You push down on the card and past a point, it'll snap down. Now it's an inverted arc. Push it up from the bottom using another finger while keeping it in compression between your original 2 fingers, and the card snaps back. That's the elastic function of this silicon oscillator, and its revolutionary quality is that it gives the watch chronometric precision that is independent of the force supplied by the mainsprings. It's a constant force device without a fusee and chain, without a remontoire d'égalité. It is an entirely new conception. It's basically this and the UN anchor escapement, and that's it in this brave new world. The timepiece using a computer-controlled electro-erosion to create this monobloc silicon component. We're into the world of microelectronics fabrication. The same technologies used to create microchips, now used to create traditional mechanical watch components. Power reserve scale at what would conventionally be 9 o'clock, and you have a sunburst metallic dial with applique indices at 12 o'clock on top of those twin mainspring barrels in parallel. The watch, the subject of 3 separate patents, and the coupling of the barrels, actually one of them. And yes, there will be a loom shot because this timepiece, with its extraordinary dial and the dial and the movement effectively one, nevertheless is a practical timekeeper and everyday reliable, and that includes every night as well. You can see this one by the light of day or night and learn more on our website. Girard Perregaux Constant Escapement LM by night. You can see they even loomed the power reserve in the lower left. This system, invented by Nicolas Dehon, actually started the project at Rolex in 1998 and worked on it for 2 years to the prototype level with Rolex. Before they decided they weren't interested, he left, joined Girard Perregaux in 2000, 8 years later had a functional prototype of this system with the silicon escapement, and finally, he had a workable watch ready for market in 2013. The rest is history. See it on the watch box.